the tutorial for Chapter 4, Section 7, which is Arithmetic Sequences. And so on this one, we've got a bunch of different sets of directions, and the first set says this: describe the pattern in each sequence, then find the next two numbers and next two terms of the sequence. And so what we look for mainly is an operation that goes from the first term to the second term. So if I look at this, I see, first of all, I typically start with addition. It looks like it's going up, so I try thinking, okay, 3 plus 3 is 6, but then when I add 3 to 12, or 3 to 6, it does not give me 12. But what I do see is if I multiply, I could do 3 times by 2, and I could get 6. And then I could do 6 times by 2, and I get 12. And then I could do 12 times by 2, and I get 24. So I see the pattern is that we are multiplying by 2. So that's what I would say. So we'll just say pattern is multiply by 2, times by 2. And then they ask for the next two numbers. So then I just take 24 and times it by 2, gives me 48. So that's the next number. And then after that, 48 times by 2, and that gives me 96. So that would be the next number after that. So pattern is times by 2, and those are the next two numbers. Looking at this next one, I see it goes from 9 to 15. So again, I typically think of adding first if it's going up in numbers. And I see that the difference, if I subtracted these two, would end up being negative or minus, or it's actually adding, so adding 6. So 9 plus 6 makes 15. And then I could add 6 to get to the 21, so that matches so far. And then I add 6 to get to the 27. So it looks like the pattern is pattern equals add 6 each time. So they want the next two terms, so I just take 27 and add 6. Gives me 33. So that's the next number. And then 33 plus 6 gives us 39. So that's the one after that. So add 6 being the pattern, and these are our different answers there. So looking at the next one, has decimals, so 1.5 to 2.25. Looks like I would add 0.75. So let's see if that pattern continues. 2.25 plus 0.75, yes, it does make 3. And this one's easy to see that, yes, you just add 0.75 to 3 and you do get 3.75. So this pattern is that we are adding 0.75 or 75 hundredths each time. Now let's find out what the numbers are. So 3.75 plus 0.75, and getting up to $4 gives you, just takes 25 cents away from the 75 cents, so it's going to be $4.50. It's going to end up being the next number higher, and from there we add 0.75 plus 0.45 leaves us with $5.25, so $5.25. So those are the answers there, and this one looks like it's going down. So again, I try subtraction. Looks like I'm going to subtract 5 to get from 12 to 7. Let's see if that pattern continues. Take 5 away from 7 leaves us with 2. Take 5 away from 2 does leave us with negative 3. So the pattern is decrease by 5, so take away 5 each time. So let's find out what the next three numbers are. So we're starting at negative 3, we're going to take 5 away, it makes negative 8, so take 5 away, negative 8, and the next one start at negative 8, take 5 away, and you end up with negative 13. So looking at the next one, we have to tell whether the sequence is arithmetic. Now arithmetic means that we add numbers consecutively, so add or subtract. But whenever we subtract, truly we are adding. We are just taking away the opposite. So add or subtract in a pattern. That's what we're looking for, and that will determine whether it's arithmetic or not. So when I look at this, that's what you have to look for, is just adding or subtracting. So don't even worry about multiplying here. If I add 4 to 8, I get there. And see here, I add 4 to 8. Oops, I add 4 to 4, I get 8. Add 4 to 8, I get 12. Add 4 to 12, and I get 16. So yes, this is arithmetic. So it's arithmetic because the common difference is 4. And so typically they use D for the common difference, and that is 4 in this case. And we definitely have arithmetic because we are adding numbers consecutively. So that's what we end up seeing there. So yes, it is arithmetic, and the common difference is 4. So again, go right to addition. I'll add 4 to the 8, and 4 to the 4, it does give me 8. But when I add 4 to 8, I don't get 16, I get 12. So this one is actually multiplying by 2 each time, and that's not arithmetic. So not arithmetic. And the reason is there's no common difference. No common difference. There needs to be a common difference in order for us to have an arithmetic sequence. And when I look at this one, I add 11 to the 12, and that gives me 23, so that does work out. And then I add 11 to 23, and that does give me 34. And when I add 11 to 34, that does give me 45. So yes, this is arithmetic, and the common difference is 11. Now if it was going down in numbers from 45 to 12, then common difference would be negative 11. So we'll just write that one out real quick. 45, 34, 23, and 12. If that pattern was going this way rather than going up, then we would say, yes, it's still arithmetic, but this time d equals negative 11 rather than positive 11. So that's what we'll see on those types. Let's take a look at another set of directions. And here it says, tell whether each sequence is arithmetic, but then we're supposed to justify our answer, so we'll do that by seeing the common difference. But then if it is an arithmetic sequence, we're going to write a recursive and an explicit formula. So we'll talk about that once we get to one. So let's take a look at the first one. So again, arithmetic means common difference. So it looks like things are going down. So let's just say it's taking away 0.8. That's what we have to do to go from 1 6/10 down to 0.8. And that's what I do again. I take away 0.8, and that gets me from 0.8 to 0. And then if I take away 0.8 again, I do get to negative 0.8. So yes, this definitely is an arithmetic sequence, and my common difference is negative 8/10. So now they want us to use or write a recursive formula for that. So recursive formula is kind of what I've done in that first problem over here, where I was writing down 3 times 2 equals 6, 6 times 2 equals 12, 12 times 2 equals 24. It's the same thing, however now we're going to use a formula to show that. So we're going to start with A1. So A1 is like the first trial, and the first trial was equal to 1.6. And so from there, we go to the second event, or the second number in the sequence. So this was the first, this is the second, and it is 0.2. And so what we do is we take that first one, 1.6, or actually this was 0.8, and we take the common difference, which is plus negative 0.8, and we go ahead and find out what that is, and it is 0.8. And so that's what the second event is. So all we do is we start with the A3, we're going to take our second event, and we are going to take the common difference and subtract it. And when I do that, I got the third event, which is 0. And see, that matches our third event right there. And then for the fourth event, I'm going to take the third event, 0, and I'm going to add on that negative 8/10 because that is my common difference. And that gives me my fourth event, which was negative 8/10. And so our formula goes this way. It goes A of n. So n could be any number is what that represents. Any number. And so in these cases it was 4, 3, 2, and 1. So it can be any number, and basically the recursive event goes this way. A of n minus 1, so the one prior, this is the one before, A of n, times by, or actually in this case, plus, and then negative 8/10. So that is the recursive formula that we ended up using there. And so now they want us to write an explicit formula. And the explicit formula allows us to pick any number and substitute in there. Here we're having to do consecutive numbers. And so I can't plug in like 50 right now because I don't know what 49 was. And so this one allows me to pick a number like 50 and plug it in here and find out exactly what it is. So the explicit formula goes this way. It says A of n equals the first event, A of 1, and then plus n minus 1. So n minus 1 would be the one prior, so one prior to the one we're looking for, times by d. And so that's what we're looking for there. So again, the nth term is any term there. N just means any term, and this just means the term beforehand, and this means the first term. First term. And so let's go ahead and try this one here. So if we plug things in, I would have this. My explicit formula would be A of n equals the first event, which was 1.6, and then add n minus 1, and so we don't know what we're going to end up using in this case, times by negative 0 and 8/10. So I'll just put that in parentheses so it doesn't look like minus, and that's it. And so again, what this is useful for is that I can take a number. Let's say I want that 50th event, so the 50th event, and so I can put in 1.6 and then plus, and then I'd use 50 minus 1, which is the 49th event, and then times by negative 8/10. And so if I did that, I would have 1.6 plus and then 49 times by negative 8/10. So we could pull up the calculator real quick, and we could do that work. So I could do 49 times by 0.8, and it's negative, so we'll change the sign there. So that makes negative 39.2, and then just add on the 1.6. And so if we go ahead and go minus 1.6, that gives me 37.6. So that would be negative, and that would be the 50th event. So that's what the explicit formula is good for. So on this one here, I see this is not arithmetic. See how it's going 5, and then I have to multiply by 2 to get to the 10, and then multiply by 2 to get to 20. So this is not arithmetic. So not arithmetic. So no use in doing that one. And on this one, we take a look at what we got. Here we're going up by 8 to get to the 13. I add 8 to 13, I do get to 21, and add 8 to 21 puts me at 29. So definitely arithmetic. So yes, and d equals 8, positive 8 this time. So the recursive goes this way again. The first event equals 5. That's what it says right here. This was the first event. The second event, well, I take that 5, and I add 8, and that's where I'm getting 13. So that's the second event. For the third event, I had to take the 13, and I had to add 8, and that's where I'm getting the 21. That represents the third event. And for the fourth event, I have to take the 21, and I add 8, that gives me the 29. So that's how I'm coming up with those numbers. So the recursive formula goes this way. A of n equals A of n minus 1, the event before the nth term that I'm looking for, plus 8. And that's the recursive formula. And so then they want the explicit formula. So the explicit formula, A of n, so any number equals A of 1, the first event, plus, and then n minus 1 times by d, the common difference. So let's go ahead and plug in the numbers. A of n equals the first event, which was 5, plus n minus 1 times by 8. And so that's the formula. So let's go ahead and try one. So let's try the 100th term to find out what the 100th term would be. So A of 100. And so I plug in that 100 in for n there, but that's going to subtract 1 from that to make 99. So I have to multiply 8 times 99 to get that answer. So that's 72. And 72 times by 9, or add 7 to 72, and that gives me 7, let's see, actually 81. So let me fix that real quick. So 81, and, or actually 80, let's see here, 72 and 7. Oh geez. So we'll try that again. 8 times 9 is 72. And then I have to carry the 7, so that makes 79. And so 792 plus the 5 gives me 797. So that's the number what the 100th term would end up being. It would be 797. So that's what the explicit formula is good for. Now let's try doing a word problem that involves those, and here they are. So that first one, it says you have a gift card for a coffee shop worth $90. Each day you use the card to get a cup of coffee for $4.10. Write a rule to represent the amount of money left on the card as an arithmetic sequence. What is the value of the card after buying 8 coffees? Alright, so let's go ahead and try it. So the first step is we're going to start off with A of n, because we're going to write the explicit formula is what they're asking for here. Let's see where that word was. So write a rule, it says, and we need to write the arithmetic sequence. And so I want to use the explicit formula because I want to find 8 coffees. So I start with what we have initially. So my first one, my A of 1, is what I start at. It's the starting point. And so I start at $90 it says. And then I'm taking away $4.10 every time I buy a cup of coffee. And so that's going to be my formula there. And so I go ahead and substitute my number in there, and I'll go ahead and plug in 8. And 8 coffees multiplied by 4 1/10, and I'm taking that away from 90. And so when I go ahead and do that work, I end up with $57.20. So looking at the next one, it says you start savings account with $200. So this is what I start with. That's the starting amount, the $200, and then I add on $30 each month. So $30 per month. I'm going to use M for months. Write a rule to represent the money you invested into your account as an arithmetic sequence. And so there it is. A of M, I'm going to call it this time, the number of months, equals 200 plus the 30M. And so from this point, they ask me, well, how much do you have in there after 12 months? So I'm just going to place 12 in for M, multiply by 30, and add 200. So that 200 was the starting amount. That's where we're getting that from. And we multiply here. This makes 360 plus 200. And that leaves me with $560. So those are the types of problems you're going to see on tonight's assignment. Good luck.